mushroom clouds snake skyward, hurling the atom's deadly radiation high into the heavens.
These are all soft, shiny, low melting point metals. We don't have to heat them up very much before they melt. And this is where we get the name alkali metals for this group of metals. If you throw one of these metals into water, you end up making an alkaline solution. But you should never take my word for something when I say that. You should say, prove it. And we go here, and we go here. So let's prove it. Okay. You should always wear these things. Okay, what we have here, let me just zoom in. What we have here are a couple of samples. Glasses that are too big is what we have. There we go. A couple of samples of some of these metals. The first one is sodium. That's not very focused, is it? I'm trying. Zoom out, zoom out. Oh, there we go. Now we've got to focus the thing now. We used to have this great camera down here, and then they spend 10 times as much money on a useless one. Are you fighting me upstairs with the focus? He is. Okay, I'll let him focus it upstairs. There we go. Now, sodium. So we have some sodium inside here. Oh, much better. Okay, there we go. Now you can see in the bottom of this, I don't know if you can see it or not, but there's a sort of an oily liquid, but over on this side there is a blob of sodium metal. So what I'm going to do is take a beaker of water, and I made the statement that if you react these metals with water, you get an alkaline solution. So how are you going to make a solution? You throw a piece of iron into water, you don't make a solution, but let's see what happens when you throw a piece of sodium into water. So I'm going to bring this over and take a piece of sodium out of this. And the oil is just to keep the air and water away from it, for reasons that will become apparent in a moment. So there's a piece of sodium metal. Okay, so it doesn't look very metallic there, but let me grab it with the tweezers and cut it. I said it was also, these are very soft metals. This is just a spatula, so I'm just going to cut into the thing with the edge of this spatula. Okay, it just cuts kind of like hard butter. And then I'm going to tip this thing up so that you can see that it is actually a shiny metal. I don't know if you can see the shiny edge there down at the bottom. See that sort of glint down here. So this is a soft, shiny metal. That's kind of a big piece. I don't think I want to risk my life quite with a piece that big. Now, I said these things react with water to form an alkaline solution. So how can we prove that it's an alkaline solution? Well, I'll take the water here, and I'm going to put some acid-base indicator into it. So it's a little bit of phenolphthalein. This will turn pink if the solution becomes alkaline. Where'd my cover go? Okay, piece of sodium, metal, and water. Turns pink immediately, so you can see that this is an alkaline solution, hence the alkali metal. This reaction is violent enough that the thing actually catches fire. Actually, it's making a neat noise, too. So sizzles away. This is the type of reason that firemen want to know what's in your lab before they come. You know, if you got some of this in your lab, spraying water is not a good idea. So that's, I think we ought to do that again, don't you? Yeah. Bigger piece, okay. I really wish I had that cover here. Okay. Sometimes it catches fire, sometimes it doesn't. And I like teaching in this classroom because there are no smoke alarms. Okay, that's sodium. Not only do we find similar chemistry in a group, but we find a progression of some of these properties. The atomic weight gets larger as you go down the group, and reactivities often increase. We expect the same sort of behavior for any element in group number 1. So we have hydrogen, lithium, sodium. Below that is potassium. There it is there. You can see a nice shiny part there. So you know the solution's alkaline already. It would also turn alkaline with the introduction of potassium. But just, maybe I'll take that big chunk and just put that away. Oh, you want to see me die or what? Okay, this is a much smaller piece than the piece of sodium that I put in. Instant flame. Very much pinker flame, hotter flame. And the reaction is almost gone. There, boom, it's gone. Well, okay, we'll put the bigger piece in. That's a lot more fun, isn't it? Somebody brought in a movie last year, a couple years ago, something they did in high school. They had a piece of sodium about the size of their forearm. They threw it off a bridge into a river. And it sank, and I guess it took a few minutes or seconds anyway for the water to get through the oil. And then it did. It just boom. It was really cool. Okay, I'm going to take away any flammable things here. That's the tutorial. I don't want that getting burned up. Okie dokie. That's the kind of thing I get in trouble for. I've been teaching in Theater B for about 6 years. The carpet's all burned up here. There's a big hole over here. So those are pretty reactive things, as you can see.